Hello, this is time value of money part 3. So in this lecture I'm gonna cover future value. I'm gonna talk about finding time period, or in other words finding investment period, finding rate of return on your investment, and finding payments. And finally I'm gonna talk about application of time value of money. At the end of this class, I hope this video is going to help you to understand how to compute future value of a single cash flow or future value of series of cash flows. You'll be able to use financial calculator or Excel spreadsheet to solve time value of money problems. You'll be able to compute investment period, rate of return on investment, and payments. For example, if you buy a house, if you borrow $100,000 to buy a house, so what is your monthly payment? Okay, so you will be able to understand the application of time value of money. So let's start. Future value. What is future value? Okay, future value is the value sometimes in future. Okay, so it is the value at some future time of a present amount of money or series of payments after you evaluate the value at the given interest rate. In other words, what is the value of a present amount after adjusting the effect of interest rate? That's the future value. So it's basically value sometimes in future. It could be a month, it could be tomorrow, it could be 1 year, it could be 6 months, it could be 10 years. So once you adjust the effect of interest during the period of the investment, or in 10 years time period, 5 years time period, so what is the value after adjusting the effect of interest rate? That's the future value. In the process of translating the present value or sets of cash flows into future value is called compounding. So we use compounding process to find the future value. Future value computed is your cash flow times 1 plus interest rate if it is one time period. If it is more than one time period, it can be computed as cash flow or your present value times 1 plus rate raised to n, which is number of periods, and this r is basically rate per period. And the period depends on compounding. If in monthly compounding, it's going to be 12. You have to divide the rate by 12, and then you have to multiply your t by compounding, so your n is going to be high. So let's just talk about this example. In this example, you have $10,000, your present value. So you want to know that what is the future value of that $10,000 if the bank pays you 5% interest rate. You want to know the future value of this $1,000 at the end of the 1 year. So basically you're gonna add 5% interest on that $10,000. Okay, so basically what you are doing here is you are finding your interest of $10,000, which is 500. 10,000 times 5%, and then you have your principal amount, which is 10,000. So 10,000 plus 500 is 10,500. So it's a pretty straightforward. You just add interest on each time period. That's the future value. So basically your $10,000 with 5% interest will grow 10,500 1 year from now. Okay, so this whole thing, this two-step process can be done in a single step. So what you can do is your present value times 1 plus r. If you do that, you're gonna get your future amount. Okay, so the total amount at the end of the investment period is called future value. That investment period could be 1 day, could be a week, could be a month, could be a year, or could be more than a year. Okay, so it could be 10 years or it could be 20 years. Here is the really nice graph. In this y-axis here, you have the future value of $1, and then this x-axis here, you have the number of years. In this case, number of years. Okay, so if your interest rate is 0%, your $1, the future value of $1 is going to be always same, no matter what, how many years. It's 5 years, 10 years, 15 years, 20 years. So if there is 0% interest rate, then we'll not be talking about present value or future value. You can just the present value or future value is going to be just same. If you have series of payments, then you can just add all the amounts, then you can find present value or future value if the interest rate is 0. However, in real life there is no 0 interest. The interest rate is more than 0. If the interest rate is more than 0, then we need to know, we need to adjust the effect of interest rate to find the future value or present value. So let's look this example with the 5%. As you can see with these yellow dots here, $1 you invest today is gonna grow to probably about $3 30 years from now. If you have 10% APR, 30 years from now probably is gonna grow to 15%, about 15%. If you have 15% APR, look at this, in 30 years you could have as much as about $50. Okay, so this is the magic of compounding. Okay, so by looking this graph here, what we can conclude is future value is always larger than the present value. Okay, given the interest rate is not 0. If the interest rate is 0, then as I mentioned earlier, we'll not be talking about future value. Okay, so one observation is future value is always larger than the present value. The second observation is higher the interest rate, okay, as you can see, higher the interest rate, higher the future value. And the third observation is longer the investment period, okay, longer the investment period, higher the future value. So this is the basic observation. This chart, this graph here shows you the future value of $1 with compounding. Okay, so let's move on. So these are the observation about future value. Future values are always larger than present values. Longer the time period, the larger the future value. Larger the interest rate, larger the future value. Okay, in other words, higher the interest rate, higher the future value. So future value is always more than the present value. Okay, so let's talk about future value formula. You can use this formula for single period or multiple periods. Single means one time period, multiple means more than one time period. So future value equals to this C0 is cash flow at time today. Okay, in other words, it's a present value multiplied by 1 plus rate per period. This R divided by M means M stands for compounding, R stands for APR. So this one, if you divide your APR by compounding, it gives you rate per period. It's a rate per period. So if it's monthly compounding, your monthly rate. Okay, so always rates are given in annual. APRs are always, discount rate is always given, the quoted rate is always annual percentage rate. So you need to know how to find out your rate per period. And if the compounding is 1, then you don't need to really do this M, and you have to divide R by M or multiply your T by M. It's going to be just 1 plus R raised to T, or you can call N. But if there is a more than one compounding, so you want to do this one. You want to adjust your rate by dividing by the compounding, and then you want to multiply your T by M to get N, number of periods. Okay, so remember this formula. Future value timeline. Suppose you deposit $100 today in your bank account and bank pays you 8% APR. How much will you have in your account 4 years from now? So that information can be presented in this timeline as follows, as shown in the picture. For example, this 1,000, your cash outflow because you are depositing, so it's present value. And then you have 1, 2, 3, 4 time periods. So you have 8% interest rate. So if you keep on adding interest on that $10,000, it does not work that way. Maybe you already know what is simple versus compounding interest. This one time period, your $1,000 is gonna earn 8% interest. Okay, so in one compounding time period, your principal amount gets interest, and next time now this your $1,000 plus your interest, which is $80. So next time period 1,080 is gonna earn interest. Okay, so every single time period your interest is gonna be added back to the principal, and your interest is gonna make interest every single time period. That's how you're gonna keep on adding your interest and find future value. This is the timeline. Okay, so if you remember from my lecture part 1, draw a timeline, identify the pattern of the cash flow, and the number 3 is use the tool, which could be formula, which could be calculator, or maybe Excel, or you can use step-by-step process, or you can use the table, time value of money tables. Okay, so how to solve that problem? Probably you are already familiar how to use Excel or financial calculator by now, but let's just use the formula here. Future value equals to cash flow times 1 plus rate per period raised to n, because I'm not doing here R by M because our compounding is annual, so I don't need to do that because 8% divided by 1 is going to be 8. Okay, so same thing here, your n equals to t because m equals to 1, so I don't need to do that. Maybe I'll show you what I'm talking about. This one, so if your compounding is annual, so this R divided by M is just R. Your T times M is N, so N equals to just T. Okay, so I'm just doing a little bit simplification here when using the formula. So your present value times 1 plus your rate raised to 4, that's gonna give you $1,360.49. Okay, so M is compounding, annual is 1, semi-annual is 2, quarterly is 4, and monthly is 12. Okay, and your number of periods is just T times M equals to 4, so your rate is 8 divided by 1 is 8. Okay, all right, let's use the easier method, easier tools. How to use financial calculator. And as I mentioned earlier, if you are talking about present value, you're gonna compute present value. So no matter what, it's present value, future value, your number of period, your interest rate or payments, you can use these 5 keys. These 5 keys in your calculator are very important. You can use these 5 keys if the cash flows are lump sum, that means single cash flow. If the cash flows are annuity, annuity means same cash flow every time period. If your cash flows are if you have single cash flow or you have series of cash flows which are same amount, then you can always use these 5 keys. You have to use cash flow function only if the cash flows are different each time period. Okay, so this is how you're going to use to solve this financial calculator to solve this problem. So n equals to 4, your interest is 8%, put your present value as cash outflow negative, and this is not the annuity problem, so put the payment is 0, compute the missing one, future value, you're gonna get 1360.49. Okay, let me show you the real calculator. Alright, let me just pull a little bit down there. Let me clean this one. Alright, so you start with just exactly like this. Is 4n 8 I by y is $1,000 and press minus sign. It's going to be present value. This is not the annuity, this is a lump sum payment. Okay, one time cash flow, so put payment equals to 0 and compute future value. Okay, this is how you're going to use your financial calculator to find future value. Do you want to see how to find future value using financial Excel? Let's try that too. Alright, so this is the future value of $1,000. Okay, so this $1,000 is gonna make interest 1 time period, 2 time period, 3 time period, 4 time period. Okay, actually not only that $1,000, at the end of the first time period, as you can see here, your 1,080. Now both principal and interest start making interest. So here now again your interest making interest again. So all of these accumulating here is future value. So you can do this step by step. Basically you multiply your present value by 1 plus r for each time period. So if you, in this case we have 4 time period, that's why. Okay, so I think I have this one is 1000. For some reason this is just being okay. All right, so for each time period you can multiply by 1 plus r, and this one also I think I 08 08 08 08. Sorry about that. So each time period multiply your $1,000 by 1 plus r. Okay, that is step by step. You can use the formula. You can use your financial calculator. I just showed you how to use financial calculator, and you can use your Excel function. If you remember from your Excel, using Excel finding present value, this is not a different. Okay, so what you're gonna do here is let me show you. Equal, okay, start with future value, close, start the parenthesis, and put your rate, which is 8%. Put your number of periods. So how many periods? 1 2 3 4. So let's put that 4. What is your payment? This is not the annuity, so put 0. And what is your present value? Put your present value. And what is the type? The payments, the when was the payment made? At the end or at the beginning? So basically you deposit $1,000 right now, so you want to put 1, but in lump sum payment, you know, it's not gonna make any difference. Okay, so you got 1360.49. Let's try if you put 0 here, it's not gonna make difference. So whenever you have lump sum payment, okay, one time lump sum payment cash flow, either you put 1 or 0, you know, ending or beginning, you know, it's not gonna make difference. Okay, so let's use time value of money table. Okay, this is a lump sum payment, so I have created a time value of money table for future value. So this table actually basically shows you the future time value of money factor. There's a future value factor for $1. Okay, so how you gonna see this, look this table is, you go rate first and then you go number of period second. Okay, so you start with rate and you go down with the period. Okay, so in this case let's check our question here. It's 8% and 4 years, right? So what you're gonna do here is you're gonna find 8%, and then you're gonna come all the way here to 8%. Okay, so this number here 1.36049. okay, so let's go to our Excel sheet here. So 1. 1.36049 0.6049. All right, so this one equals to present value times that factor. Okay, so present value equals to present value times that factor, which is 1.36049. Okay, so that's how you're going to use your time value of money table. So look the rate and then go down the number of period. So in this case, this 1.36049. Okay, the time value of money table has some limitation. You can have table only for lump sum payments and annuity. If you have uneven cash flows, then you can't use time value of money. You have to use, still you can use it, but you have to do step-by-step process. Okay, so I think this time value of money table is really easy to create. I think if you know how to use financial calculator, how to use Excel, that would be a lot better. I've been keep on telling you, it's very important you understand what is the meaning of these 5 keys. You can summarize the problem in 5 keys. That's the key. Either you use Excel or financial calculator, please understand how these keys are defined. How do you define these keys? What is N means? What is I by Y means? What is PV means? What is PMT means? What is future value stands for? You will have one missing and you have other information. So know how to put these numbers correctly in your Excel or financial calculator. Alright, so let's move on. Alright, what happens if the compounding is more than 1? Okay, in this case the same problem, but you have 8% annual percentage rate which is compounding monthly. That means every month your interest is gonna make interest. There are 2 ways you can solve this problem. One way, if you remember, this N, I by Y and PMT, they have to match. In this case the PMT is 0, so it does not really matters. You can just put 0 every time. You can put 0 for all time periods. So you can multiply your T by compounding, so which is 4 times 12 equals to 48. That's good. That's fine, because you don't have to worry about this PMT. It's 0 every time period. Your I by Y, which is rate of return or discount rate per period, in this case you have 8% annual, so you want to convert to monthly. So you divide 8 by 12, which is gonna give you 0.6667. Okay, and this is standard. You just put negative present value and compute future value. You can have this one. Or if you don't want to change your N to periods, you can just leave that N equals to 4, and you can change your rate to effective rate, and then you can solve this problem. Okay, so let me show you how to solve this problem using financial calculator. Alright, so let me start with your N. First let's do exactly what I have done here. Your N is T is 4 times N compounding is 12, so it's 48. So you have 8% APR, so rate per period is 8 divided by 12, which is 0.6667. Okay, The next thing you're gonna do is 1000 negative, so present value, payment equals to 0, compute future value. Okay, so you got your answer. We also can do this one differently. Okay, so that's why I'm saying understand these 5 keys is the key. How about you just convert your interest to effective interest and solve this problem? Okay, so let's convert our interest to effective. How do you do that? Second, and icon. Let me clean this one. So we have 8% monthly compounding, so 8, and then define your compounding, go up. So it's already here 12. So I guess I had that 12 last time, so I didn't clean that. So enter, go up, compute effective. So which is 8% is actually 8.3%. Okay, now let me store this number. You can directly put this number in I by Y. So you can do, let me first store this one. I want to store this number here. Okay, in case I need for future. So also I want to put this one directly here and quit. Let me check if this number is stored here. Alright, so I by Y is 8.3%. Now let's start with N. So since you adjust your interest rate, you don't have to adjust your N. So N is 4. I by Y already have that number. My present value is 1000. My payment is 0. Compute future value. Did you get the same answer? Definitely yes, right? So understanding these 5 keys is the key. Now if you have quarterly compounding, what would be your future value? If you have semi-annual compounding, what would be your future value? I have given you the answer here, so please try yourself. This is for you to practice. Alright, so let's move on. So another example of future value. Suppose you deposit $1,000 today in your bank account and bank pays you 8% APR. So how much money will you have in your bank account 5 years from now? So this one is pretty straightforward. So N is 5, I by Y is 8%. So always put whole number in calculator. Your present value is negative $1,000. Your payment is 0. Compute for future value. You get 1,469.33. You practice that. Okay, so I'll leave this one for you to practice. So notice that your future value is, we just computed and we got that $1,469.33 is higher than your original deposit, right? So plus 5 years of 8% simple interest rate in your original amount. If you have simple interest rate, every time period your principal is going to make interest, right? So your interest does not make interest. So if you had no compounding, your future value would be just $1,400. You have this 69.33 extra money. This is because of the compounding. So hopefully now you understand what does that compounding means. Compounding means your interest is going to make interest every single time period. Okay, so first time you have principal amount, now second time your principal and interest, both of them, they're gonna start making interest. Okay, so this is because of the compounding. So I have just put that example with this demonstration here. So you $1,000 making interest, so which made $80 at the end of the first year, and then the second year your 1080 makes interest, so you have 1166. I have rounded this number to, by the way. And then third year, so actually $1,000 times 1 plus R, 1 plus R, 1 plus R. $1,000 times 1 plus R times 1 plus R times 1 plus R. This is your future value at the end of the third year, future value at the end of the fourth year, future value at the end of the fifth year. Okay, so this is how you do compounding, find future value. Okay, let's think about an example. Suppose a stock currently pays a dollar dividend, pays a dividend of $1.1 and is expected to grow 40% per year for next 5 years. So what will be the dividend at the end of the 5 years? Okay, that's basically, it's a simple example. I'm not telling you directly here find the future value, but you're gonna find the future value of $1.1 with 40% growth rate. Okay, so basically use the same formula. So you can use the financial calculator definitely. So this N is going to be 5, your I by Y is going to be 40, and your present value is going to be 1.1. Okay, and then your payment is going to be 0. Compute future value, you're going to get 5.92. If you use the formula, it's 1.1 times 1 plus 40% raised to 5, that's going to give you 5.92. So this is the simple example, does not tell you find the future value, but you know, if you can identify those 5 keys, that's the key. Another example, okay, suppose you deposit $50 in your bank account and the bank pays you 12% compounding interest, semi-annual compounding interest, and you want to know how much you'll have in your bank account or in your investment account at the end of the third year. So use the same formula, the present value times 1 plus a rate per period. So in this case your compounding is 2, so 12 divided by 2. So since you adjust your interest, you have to adjust your N. Okay, so 50 times 1.06 raised to 6 equals to $70.93. Okay, and same thing here, your N is going to be 3 years times 2 is 6. Your I by Y is 12 divided by 2 is 6, and your payment is definitely, it's not annuity, is 0. Your present value is negative 50. Compute future value, you get the same answer. And if you define the same thing in Excel, you're gonna get the same thing. I just did in my previous problem using Excel, so hopefully that would help you. All right, so how about the same problem? We just did this problem right here, which is semi-annual compounding 12%. Is there another way you can solve this problem? Definitely. You can convert your APR to effective APR and use that effective APR so you don't have to adjust your N. Okay, so how do you find APR, effective rate, using formula? This is 1 plus your APR divided by compounding, whole thing raised to compounding, minus 1 equals to 12.36. If you want me to do that, let's look this. Okay, so you're gonna use second icon, and let's clean this one, which is, now we have your APR is 12%, nominal rate, which is called nominal rate, go up, and your compounding is, let's see, is 2, some semi-annual. Okay, it's compounding per year. 2, go up, compute, so it's 12 and 36, right? So let's just put that 12 and 36 here in your interest. So your N is 3 now in this case, and we already put that I by Y. Your present value is $50, and you want to put present value as a negative, like cash outflow. Payment is 0. Compute for future value. This is how you're going to use financial calculator. Okay, so the key again is using understanding how these 5 keys work. Okay, all right, so let's move on. We have a lot of things to finish. All right, so we just finished this one. This is I'm just showing step by step. If you have $2,000, oh, by the way, this one, now we are talking about annuity. Okay, so if you have the annuity, future value of annuity is calculated by compounding each cash flow separately. Okay, so you're gonna find the future value of each of these cash flows and add them together. That's the future value. So as you can see, there's a lot of work, right? You are finding the future value of each cash flows and adding them together to find the future value. So from here we start finding the future value of annuity. Okay, the annuity could be in the beginning of the time period and at the end of the time period. So depending on the time, cash flow timing, we're gonna adjust that. But if you watch your previous video, present value part 2, that's gonna be very helpful. I have explained everything in detail, timing of the cash flow. So let's start from here. It's future value of annuity. Annuity means every single year you're gonna have same cash flow. Okay, so which is called ordinary annuity. So here is the formula for future value of ordinary annuity. Okay, so you can plug the numbers here. C is $2,000. Your R is 10%. Your timing is 5. Your R is here is 0.1, and then do all this math, do -1, and you can get the future value. Okay, so I guess using calculator is a lot easier and fun to use. So let's use a financial calculator. Now we are talking about ordinary annuity. Okay, if you have more than one cash flows, how do you find future value? As I mentioned earlier, again we are using 5 keys. Okay, so now we used to use the present value, put number in present value. Now what we are saying here is we are telling the calculator that, let's look this one. Okay, you have you have cash flows 1 2 3 4 5. You have 5 cash flows. Okay, so we are telling 5 here and cash flows here. Okay, you have 5 cash flows. Cash flows, this is payment. How many? 5. Okay, so depending on the cash flow, if it's you got the money, you put a positive number, you have cash outflow, in other words, you are investing or you are paying, you are depositing money on your bank account, or in your retirement account, we're gonna put negative sign. So this negative sign is cash outflow convention. Future value is normally positive, so we want to make that future value positive here. So your interest rate is 10%. In this case, you don't have any present value, you have only payments. So put this number in your financial calculator Okay, so let's use financial calculator now. And how to, it's pretty straightforward. You already know how to use it, but let me show you. You have n is 5, your interest is 10%, your present value is 0 in this case, your payment is 2000, negative, compute future value. So it's pretty straightforward. Okay, what happens if you don't put payment is positive? Payment is positive. Okay, if you put your payment positive, you're gonna get your future value negative, which is normally not appropriate. Future value is normally you know to cash inflow. So it should be a positive, but it does not really matter here in this case. You can still have a negative number, but when you write your answer, just put a positive number. So it's up to you. Okay. All right. So let's use the Excel. How to use Excel to find future value of these annuities. Okay. If you remember from my earlier lecture, there are two types of annuity. Ordinary annuity, which means the cash flows are at the end of the time period. Okay, the cash flows are at the end of the time period, like this one. And annuity due, which is cash flows are at the beginning of the time period. Okay, so let's look our question. You have $500 cash flow at the end of the year for next 4 years. Bank pays you 9% interest compounding annually. What is the present value of all future cash flows? Or, sorry, what is the present value of all cash flows? Or how much you'll have at the end of the 4th year? So since we are doing future value, let's ignore this present value, okay? Because we already did that present value in our earlier lecture. So let's do future value with ordinary annuity and annuity due. So let me I just opened my Excel file. So I just don't want this one because the rate there is messed up again. Okay, because that's 11%, 9%. All right, so as you know that you're gonna put your cash flows in timeline and then use appropriate tools to solve this future value problem. And as I said earlier, you can use step by step, or you can use formula. In this case, now I want to do directly Excel. Okay. All right, how do you do future value in Excel? You're gonna start with future value. Okay, and then you will put the rate, and then number of payments. So how many? 1 2 3 4. And what is your present value? Present value is 0 because this is annuity. And finally, what is, so let's see here, we put the rate, we put the number of periods, and then okay, we missed that payment. So what is the payment? Payment is $500. Okay, $500. Let's put that number, and don't forget to put negative. Okay, and then finally then you have to put present value. Present value is, in this case, you don't have anything here, so let's put 0. Okay, then now whenever you are talking about annuity, it's very key. You know what is that 0 and 1 means. This is ordinary annuity. As you can see, the cash flows are at the end of each time period, so you want to put 0. Definitely you want to put 0 here. Okay, you close the parenthesis, you got your answer. Okay, you can also use formula, going here, find future value, and you can define your rate, which is 9%. Your number of period is 4. Your payment is 500. Your present value is 0. Your type is, so it's going to tell you what is the type means. Okay, if you don't put anything, it's going to treat like 0. So okay, in this case we just want to, you can leave, not, you know, you don't, if you don't want to put anything, that's fine. But let's have a habit to put something. Let's know exactly what does that mean, and should be, it's already giving you, so make sure you put this number is negative. Okay, so this is how you're gonna get your future value. You can use sorry, it's twice. Okay, this is how you're gonna use your Excel. So the bottom line here is these 5 keys. Okay, defining these 5 keys. Same thing in calculator, same thing in financial, in Excel. Actually you can create a financial calculator in Excel. So how about this if it's annuity due, how do you find out the future value? Okay, let's go back to our Excel, and let's look this one. So if you have annuity due, that means the payments are made in the beginning of each time period. So how do you find the future value? Again, same thing. Only thing difference is you define when the cash flows are made. Okay, so future value, and your rate is 9% in this case, and your number of period is 4. Your payment is $500. Let's put negative $500, and your present value is 0. Then your type is, definitely, is this the beginning or end? As you can see here, it's right now. Each cash flows are made in the beginning of each time period. Okay, so that means your first cash flow starts making interest right away. That's why it's very important. You have to say it's 1. Okay, close the parenthesis. Okay, you have 2492.36, which is more than your annuity, ordinary annuity. Okay, your ordinary annuity is 2286.56, right? It's different. Why? The reason for that is your first payment starts making interest only end of the first year, and your final payment will not make any interest. Look at that, because future value of 5 years is your 5th cash flow, the 4th cash flow is at the end of the 4th year. So the future value of the 4th cash flow end of the 4th year is just $500. Okay, so you have one more period you are making interest. So you can just multiply the answer from your ordinary annuity calculation, get the answer for ordinary annuity, multiply by 1 plus r. Okay, multiply by 1 plus r, and you can get the same answer. So let's try this one. So your present value of ordinary annuity multiplied by 1 plus interest rate. Okay. All right, you get the same answer, right? So understanding those 5 keys, understanding the effect of interest rate, really important. All right, let's go back to our, oh, by the way, let's use the table. If you use the table, you're gonna have to look the table. So it's a future value of ordinary annuity. Okay, so your problem says it's 9% APR compounding annually, and let's see, it's a 9% compounding annually. It's a $500 4 years. Okay, so you're gonna have present, it's a future value factor is it's gonna be 5%, 9%, 4 years. Okay, so 9%, let's find 9% and let's find 4. Okay, so right here 4.57313, 4.57313. Okay, so this one equals to your 500 times 4 point, I forgot that number. Okay, so let's use this 9% right here. Okay, I copy that. So did you get the same answer? Yes, you did, right? So you can use your financial time value of money tables too to find the future value of ordinary annuity or annuity due. So let's see the annuity due table. This is ordinary annuity. Probably I don't have that. Okay, I guess I don't have that table. So tables has the limitation. Tables have the limitation. So it's always is good idea to use either Excel or financial calculator. Once you know it, you can create your own table. All right. So before we finish this lecture, we have to finish some important materials. So let's go and look our financial calculator. So how to use financial calculator? Here in this case I showed you how to use Excel. Financial calculator, same thing again and again. I'm saying you is ordinary annuity. So your N is 4, your interest is 9%, your present value is 0, your payment is $500. Put negative, compute future value. Okay, this is ordinary annuity, future value of ordinary annuity. All right, now how do you find out the answer for annuity due? Okay, the way you can find the answer is, I showed you in Excel, you can multiply your answer by 1 plus R. Okay, so let's do that, because in annuity due you're gonna make interest one more time, right? So you multiply by 1.09. okay, you get 2492. So future value of annuity due equals to future value of ordinary annuity times 1 plus R. That's what I did here, and I got my answer. Another way to solve it, the same problem, is using the mode of the calculator. Okay, by default this financial calculator is N mode. In other words, this calculator by default will assume that all the cash flows are made at the end of the time period. Okay, for annuity, all the annuity at the end of the time period. The calculator has that function by default. So if we want to define the cash flows in the beginning of the time period, you have to change the mode. It's the same as your previous lecture. Okay, second payment, which is going to bring you beginning. So let's follow the instruction. It says set again, second. Now you change to beginning mode. As you know that we already put the numbers here, right? So we don't have to put all the numbers again because these numbers are already there. Okay, these numbers are already there. So I'm just checking, recall, and press that number. Okay, so, and this future value doesn't matter because we are computing. Okay, so all you need to do is change the mode in the beginning mode. Tell the calculator the cash flows are made in the beginning of the time period. Okay, in your homework problem, the first homework problem, you have assume cash flows are made in the beginning and the end. That's what I'm talking about. Alright, so once you change the mode, you already have these numbers. You press compute and future value, you have your solution here. Okay, you have your solution here. It's up to you which one you want to use. Use the one that does not confuse you. Okay, personally I prefer just multiplying answer from ordinary annuity by 1 plus r because I don't have to change the mode. Okay, so one thing I would like to remind you that most of your problems are in regular mode. So I want to make sure I change the mode. If you see something BGN here, that's not good. So you want to make sure that you change your calculator mode. Otherwise, you're gonna mess up all your solution. Second payment, second set, second quit. Now you don't see anything BGN. Okay, that means you are good to go. All right. How about if you have 9% compounding monthly? How do you get present value? And I'm solving only ordinary annuity in this case. Okay, so if you remember, your N, I by Y, and PMT must match. Since the payments are annual, you cannot mess up with your payment. Your payment must be annual. So there is no way we can divide that payment by compounding. N, you can convert your N, you can adjust your N with compounding. However, you cannot adjust your payment. In lump sum problem, your payment is 0. That's why you can, 0 is 0 no matter what compounding, right? But in this case, payment at the end of the time period or in the beginning of the time period, you cannot say your payment every month. You cannot change your payments to every compounding time period. So all you can change here is your interest. So again, you're going to change your APR to effective rate. So understand, when you change your interest to effective rate, most of the time, you can find you are fine. You can change your N, I by Y, and solve the problems. That's fine. But if you have annuity, then you cannot change your N. You have to change your I by Y, which is convert your interest to effective rate. And I have shown you several times. You can use the formula or you can use the Excel. Just to show you again, second interest conversion. Let's clean this one. You have 9% nominal rate, go up. In this case your monthly compounding, so put 12, go up, compute effective rate, which is 9.38, so put here. Okay, so what I did was I compute effective rate and put on your I by Y. Now your n is 4, your n is 4, your present value is 0, your payment is $500. Compute future value. Okay, I'm finding the future value of ordinary annuity with 9% compounding monthly. You can try the other one. Okay, all right, so let's move on. How about if you have you know, uneven cash flows? In other words, if your cash flows again still they are annual, but if the cash flows are different, which is called uneven cash flows. Okay, and you have the same problem, so you have the similar problems, but in this case your cash flows are not same. Every time period your cash flows are changing. So first year 500, second year 600, third year 700, fourth year 800. APR is 5%, 9%, compounding annually. So what will be your future value at the end of the fourth year? Assume your cash flows are made at the end. Assume your cash flows are made in the beginning. Okay, so let's use financial Excel. All right, Excel here. This is the future value of uneven cash flows. Okay, so we treat as ordinary because end of the time period. Okay, and then we want to find out the future value if the cash flows are made in the beginning of the time period. Okay, so we are looking both ways. Now in Excel, how do you do that? How to find out the future value of uneven cash flows? If you remember, if you have uneven cash flows, we cannot use 5 keys. Okay, in your calculator. In the same way, in your Excel also, you don't have that future value of annuity function. At least I don't know that if Excel has that one. Let me try. Future value is that what that schedule means? Okay. Principal. I don't think, as far as I know, there is no. So I don't know, I don't remember if there is any future value of annuity uneven cash flows in in Excel or in financial calculator. In financial calculator, in professional version, it has that, but in regular calculator, there is no future value of the uneven cash flows. Okay, so what we're gonna do here is we're gonna use whatever we know, which is we can find the present value of all the cash flows using NPV function. Remember, in your last lecture, present value I explained in detail. Okay, so what we're gonna do here is we're gonna use 2 steps. If you use step by step, definitely you can do that, but if the cash flows are changing over time, you cannot use future value function. Okay, so and also you cannot use present value function if the cash flows are changing. So what we're gonna do is find the present value using NPV function. Okay, equals to NPV, and your rate is 9%, and then your values are these cash flows. Close the parenthesis. So you got your present value. Once you know the present value, can you find the future value? So your present value is this one. Let me summarize here. Your N, your N, I by Y, your present value, your PMT, future value. You know that, right? So N in this case is 1, 2, 3, 4, and your I by Y is annual compounding 9%, so which is 9%, and then your present value is, put present value is negative, so we just find out present value using NPV function. Okay, and your payment is, since you already took care of the payments because you use the payments to find present value, so you cannot put payments. These are different. You cannot use the same number twice, so put 0. So you have to compute your future value. Okay, so you have to compute your future value. So how do you do that? Equals to future value, and rate is 9%, your N is 4, your payment is 0, your present value is this number, your type does not really matter. Okay, so this is like just like lump sum, future value of lump sum. Okay, enter. Okay, so did you get your that's what I did here. Okay, this is how you're gonna use the same information. Once find the present value using NPV function, because you have to do NPV function since the cash flows are uneven. You cannot use present value function. You have to use NPV function. Okay, once you find the present value, and it's very easy because that present value is just lump sum amount. Okay, now you can convert that present value to future value using the 5 keys. Okay, so whenever you have cash flows, they are uneven, you have to use 2 steps in Excel, in financial calculator, in both places. Okay, now let's think about if the cash flows are made in the beginning of the time period, how do you solve the problems? Okay, cash flows are made in the beginning of the time period. All right, the easiest thing you can do is, as you know that the present value or future value of annuity due, which is the cash flows are made in the beginning. This is also similar. Okay, the cash flows are made in the beginning of the time period. So your answer for if the cash flows are made in the beginning, what you can do is you can multiply your answer from this first annuity ordinary problem. You multiply by 1 plus r, you can get the solution for the other one. Okay, so if you multiply this number by 1 plus r, which is 9%, you should get your answer. As you see, you got your answer. If you want to know in detail, that's fine, I can explain you. First of all, find out the present value of these cash flows using NPV. So use NPV equals to NPV. In both financial calculator and in Excel, If you have series of cash flows, they are different. The financial calculator in Excel is assume that the cash flows are made at the end. Okay, so you have to just adjust that manually. So NPV equals to 9. So you start with parentheses, put the rate, and then select the values. It's exactly same way you did for the previous problem. Okay, once you find the answer for ordinary, then you find the future value exactly same way. You find the future value and you multiply by 1 plus r. So as you can see here, actually you don't have to do all these things. You can directly multiply by that answer by 1 plus r to get the answer for if the cash flows are made in the beginning. Okay, if this is a future value of cash flows is like ordinary annuity due. So this is how you're gonna find this one. Okay, next thing we're gonna do here is we're gonna use financial calculator. Okay, so financial calculator, I'm not gonna spend too much time now because we did this one in present value calculation. So we're gonna use the same process. Use your cash flow worksheet on your financial calculator. So press CF and then second and clear so that you can make it clean, and put the first number is always the cost, cash flow at time 0. So in this case put 0 and go down, put 500, your first cash flow. Go down, how many times you got 500? One time, so leave 1. Your second cash flow is $600. Enter. Down, leave 1 because you got one time. A third cash flow is $700. Enter. Down, fourth cash flow is $800. Enter. Down, and then exit the cash flow worksheet. Okay, once you enter, then you're gonna use NPV function. It's similar to your Excel. Use NPV function. Put your interest rate, which is 9%. Okay, go down. Alright, and compute NPV. You got your NPV. Okay, so this NPV is same as present value. So since this calculator does not have NFB calculation, your calculator, this professional version has the NFB calculation, I guess, but most of the calculator, they do not have this function. So what you need to do is, once you know the present value, then you can find out the future value. That's the bottom line. Okay, so once you find this present value, put that number is negative and put in present value. Now quit. So your N, its N is 4, your interest is 9%, and I just put present value. Oh, let me recall that. Okay, I need to go to NPV down. So let's put negative and put here in. Let me store this one here just in case. Okay, let me check now. Alright, so present value is put that number as negative, and payment is 0 because you already took care of the payments. To find present value, compute future value. Okay, so you got your future value. It's just exactly same as we did in Excel. Okay, now Let's go to the next slide and look. This is if you assume that the cash flows are made at the end of the time period, at the beginning of the time period. Sorry, this annuity due, the cash flows are made in the beginning of the time period. So as I mentioned earlier, this cash flow worksheet and Excel assume that the cash flows are made at the end. So if you have the cash flows are made in the beginning of the time period, then what you need to do is your cash flows are making interest one more time period. So what you can do is just use this same cash flow function and find out the present value. Okay, find out the present value, then find the future value. Once you find the future value, you multiply your answer by 1 plus r. So you multiply this answer by 1.09. That's gonna give you the future value if the cash flows are made in the beginning of each time period. Okay, so basically I use two different things: 5 keys and cash flow function. When I use cash flow function, I have to use NPV. Okay, so this is how you're gonna use financial calculator and Excel to find the future value. Alright, let's move on. If you have future value growing annuity, which means you have the cash flow is growing at the constant rate until certain time in future. So if you have that case, you're gonna use this formula here, and I'm not gonna go in detail, but you can easily plug those number there. If you have future value of continuous compounding, that means it's continuously interest is making interest. What you can do is you can multiply your present value by e raised to r times t, which means here is the explanation. C0 is cash flow at time 0, which is present value. R is APR. T is number of years. E is that 2.718 in your financial calculator. It's right here. In if you use second and ln, you're gonna have this e raised to x. Okay, so you can use that function easily here. So I'm done with the future value. It's really important, but you're gonna understand this one only if you go over the previous lecture. So time value part 2, okay, which exclusively deals with the present value problems. Now until now we are done with future value. Okay, so let's move on. Next slide will show just briefly revisiting. Okay, the next slide is briefly revisiting future value and present value of annuity, ordinary annuity and annuity due. So you can try to solve this one. Okay, if you solve for future value using 5 keys, you should have this answer. If you solve for a present value, you should have this answer. Same thing here. So please try yourself and feel comfortable. Practice as until you feel really comfortable about it. All right. Now in your financial calculator, we have 5 keys. N, which stands for number of period. If you divide number of period by compounding, you're gonna get your investment time. How long you have to wait to have your 5,000 grown to $10,000. Okay, how long you have to wait to double your initial investment of $5,000? Things like that. That's a number of years. Okay, and we are solving for years, which is find first n and then you divide by compounding. Your same way we have to, if you solve for I by y, you're gonna find your rate of return. If you are solving PMT, for PMT you're gonna find the payments. So as I mentioned earlier, you're gonna have some information and some missing information, one missing information, you are finding that one. So if you use calculator, if you use suppose if you deposit $500 today and bank pays you 10% APR, how long is going to take for you for that $5,000 to grow $10,000? So basically you are finding your time, investment horizon, or how long is the wait time. Okay, so if you use this future value formula and solve for this t, you're gonna get the answer, which is 7.27. Look at this, this is a very complicated mathematics here, so we don't want to do this one. So what you can do is you define this problem. So your deposit today, which is present value, is a negative, and your $10,000 is future value. This is not the annuity, so you put a 0, and you know your interest rate 10%. Don't put percent, just put the whole number, and you don't know your n. Compute n is gonna give you 7.27. Since this one is does not tell you compounding monthly or semi-annually, it's annual compounding, so your n is same as years. Okay, let's use calculator. Very easy. Alright, so my n is, I don't know, interest is 10%, present value is 5,000, and present value is your cash outflow, payment is 0, future value is $10,000. Compute for n, which is 7.27 years. Alright, let's move on. Next slide, finding rate of return. Again, you can use the same formula and you can solve for R. Again, as you can see, it's a lot of steps are here. So let's use the financial calculator. Alright, let's use the financial calculator. Let's define our inputs. Our inputs is, the problem says you have 12 years. Okay, you have 12 years, so n is 12. So assume that the total cost of the college education will be $50,000. $50,000 when your child enters college in 12 years. So you definitely know that that $50,000 is your future value, right? That's your future value. And you have $5,000 to invest today. Okay, so you have $5,000 to invest today. That's the present value. It's not the annuity. Okay, so you have $5,000. You invest means cash outflow, negative. Alright, so we have our n, we have our p present value, we have our future value. This is not the annuity problem, so payment is 0. Alright, so we put all this information, n, present value, payment, and future value. Okay, so what is the missing one? Our interest rate. So what interest rate is gonna make your $5,000 to $50,000? Okay, so to grow your $5,000 to $50,000 in 12 years, what rate of return you should make? You compute I by Y, which is 21.15%. All right, so these 5 keys are very, very useful. All you need to know is how to define the problem. Okay, let's go to the next slide and compute our payments. All right, and as I mentioned, you can also use your Excel. Okay, and I have talked about that exclusively in my previous lecture, so please check that. So you can use Excel function to find out your I by Y, in other words your N, your interest and payments. Okay, so let me use financial calculator here in this case too. Alright, suppose you want to have $50,000 for your child's education 12 years from now, and okay, so you like to invest annually. Okay, you want to invest annually to make that $50,000. You have 12 years time period. You'll make your first payment exactly 1 year from now. So if your investment pays 11% annual percentage rate, how much do you need to invest annually to cover the cost of your child's education? So which means is, if you see this one at the end of the year, that's a annuity, ordinary annuity problem. Okay, so let's start with the calculator. So you know your timing, you have 12 years. You know your interest is 11%, and right now you don't have anything, but you want to make $50,000 end of 12 years. To achieve that objective, okay, how much money do you need to deposit every year or invest every year? And you know that the investment you're going to make at the end of each year. Okay, so how much money you have to deposit? You put all these inputs, solve for the one you don't know. Okay, so 12 and 11, I by Y, 0, present value, $50,000, future value, compute, payments. Okay, so you have to put $2,201.36 on your bank account, or in your child's education, to support your child's education 12 years from now. Okay, all right, let's move on. So we use all these 5 keys. Next one, next couple of slides, I'm going to be briefly talking about the application of time value of money, because so in this topic, time value of money, I cover the most important things: present value, future value. Okay, that covers almost everything. And also I showed you how to compute your number of periods, or in the other words, timing. I also showed you how to find out interest rate. Okay, I didn't go in detail. Later on we're gonna find rate of return if your investment, if your cash flows are different. But in this case, I just use a simple example. If the cash flows are lump sum or annuity, how to find out the interest rate, we did that too. And also we found the payments, and I'm gonna post another lecture video which will exclusively deal with amortization, finding payments, your house payments. Okay, so I'll post another video on that. But right now, since I cover most of the important material in time value of money, I would like to just briefly talk about the application of time value of money. Let me tell you something here. If you have 2 projects, and these projects are expected to produce same cash flows in future, but A cost you more than B, which would you prefer? Okay, so this is the one of the application. You have 2 investment choice. Using time value of money concept, you're gonna choose these projects. Similarly, if you have 2 projects, C and D, they cost you the same, but D produce more cash flows in future than C. which would you choose? That's another application. Suppose security E and F, they have the same risk. If E pays you $100 in 2 years and F pays you $108 in 3 years, and the rate of return or interest rate in the market is 10%, which one do you choose? Which one do you prefer? Okay, so let's look this third problem. In the beginning of this lecture series, I explained you the time value of money is just a tool. It's going to help you compare cash flows in different timing. In other words, you have two different fruits, apple and orange, and time value of money can help you. For example, this $100 is your apple, your $108 is your orange. Okay, because two different timing is 2 years and 3 years. Okay, so how do you compare this $100 2 years from now and $108 3 years from now? The time value of money will help you to compare these numbers by making them same. So you can convert your apple to orange or orange to apple. In other words, you can convert your $100 to future value, which is the future. You can find the future value of $100 1 year from now, or you can convert your $108 discounting 1 year. So you can convert to 2 years value. Okay, so let's look this one. In other words, what you can do is actually you can find the present value of all these this number and this number here, and you can compare. That's the one way you can do it. Other way you can do is just find the present value of this. You can discount $108 just one time and compare. That's another way. The third way you can do is you can convert the value of $100. Find the future value of $100. So $100 times 1 plus the rate is 110. So now you have 108 and 110. Which one is better? Definitely future value of E is greater than future value of F. So this is how you're going to use time value of money concept in your investment decision. Therefore, time value of money is very important concept. By understanding time value of money, you can solve several problems in finance very easily. Okay, if you understand time value of money in depth, you'll have no problems in any other chapters in this corporate finance course. Okay, or you can find the present value of all these two projects. So find out the present value of $100, find the present value of $108, and compare the present value. So if you do that, still the present value of project E is higher, so you prefer that. Okay, so project E is preferable. When you do capital budgeting, later on we're gonna deal with net present value. Net present value is basically present value minus your investment. Suppose your investment promised to pay $10,000 in 1 year from now, and right now it's going to cost you $9,500 if the interest rate is 5%. Should you invest? Now we are talking about capital budgeting problems. Okay, so we're gonna find out the net present value. net present value is just the present value minus the cost. So it's going to cost you $9,500 and you're going to get $10,000. So you find net present value. Net present value is $23.81, which is more than zero. So it's a good project. Therefore, you're going to choose this investment. So you see another application of time value of money. So time value of money is the key. You need to know time value of money for capital budgeting decision. So here is in more detail. So your net present value is present value minus cost or your initial investment. So your present value minus cost, and we did that here in previous slide. Okay, the present value of $10,000 is $9,523.81. Your cost is $9,500, so still it's positive number. It's greater than zero, so it's a good project. You accept this project. So this is another application of time value of money. Another application of time value of money is, let's think about retirement planning. You assume that you have 40 years to work and you want to save for the retirement annually. Your first saving deposit, you're going to deposit $3,600 at the end of the first year, at the end of each year. Okay, let's say you're going to deposit $3,600, or you're going to have $3,600 in your retirement account at the end of each year. If you earn 10% return on your retirement account, how much will you have when you retire at the age of 40 years? So this is the example, one example how you can use time value of money concept in your retirement planning. Okay, so I'm just putting this one in timeline. So you start, it's a annuity problem, ordinary annuity. So you deposit your first invest at the end of the first each year. So and you stop at the age of 40, not at the age of 40, it's at the end of 40 years. Probably you are maybe about 30 years, maybe you want to work, maybe you are about 20 years, you want to retire at 60. So this is you are planning for your retirement. So how do you solve this problem? How much should you will you have in your retirement account at the end of the 40 years? Okay, and another example is, now if you believe that you're gonna survive 25 years after your retirement, okay, and when you retire you don't want to put your money in the risky investment, you want to put your money in CD which pays you 3%. Okay, so if your first retirement withdrawal occurs 1 year after the retirement, how much money can you withdraw each year? Okay, so this retirement problem I'm putting in two parts. First, you're gonna invest, and then second, you're gonna withdraw money, right? Until you retire here, you're gonna invest $3,600. Okay, and you want to know that how much money you can get each year when you retire. That's your question. So you are basically looking for the payments. Okay, so this is a two-step problem. Try to come up with timeline. So what you're gonna do is you're gonna find the future value of all your investment in retirement account, So you find the future value, and once you find the future value, using that future value as present value for your retirement and solve for the payments. Okay, so in this case you have ordinary annuity, and in this case you are solving for payments. You have lump sum amount, you are solving for payments. Okay, so two parts of this problem. Alright, so let's solve it. I'm using financial calculator. So first I find my future value. So I want to know how much I will have at the end of 40 years when I retire. Then I can make a plan how much I can withdraw, right? So first of all, you need to know how much money you will have when you retire. So you have 40 years and you have 10% APR. You're gonna start investing at the end of the first year. So right now you have no money in your retirement account, and your investment is gonna be $3,600 each month. Okay, so cash outflow, put negative. Compute future value. So when you retire here, you know exactly how much you will have. Okay, once you know how much money you will have when you retire, then you can find out the payments, how much money you can withdraw. And you are saying you're gonna survive 25 years after the retirement, and you're gonna put your money on safe account. So you don't need 10%, you just want little 3%. You want to put your money in the safe investment. So your present value is this number. Your future value when you retire is present value for your retirement timing. So put that number as a negative number and compute for your payments. And future value for the second one is 0, because when people at the end of the retirement people die, right? So let's assume that this person is gonna die at the end of the 25 years. So if that's the case, this is the payment. So let me show you using the financial calculator. Alright, we have 40 years to invest, and your investment pays you 10% every year, and you're gonna start investment at the end of the first year. So your present value is 0. Your investment is $3,600 each year. Let me put one more 0. Your payment is $3,600, and your future value is 0. Okay, so what is the missing one? Sorry, you are actually finding future value, right? So you are computing future value. Okay, you got your future value. Once you get your future value, you want to save your future value somewhere here. Okay, now this person retires at the end of 40 years. Okay, and then put the money in some safer accounts. Okay, has 25 years to go. So he wants to withdraw money for 25 years. Okay, end of each year. So 25 N, and he wants to put the money in safer account, so pays very little interest, and the present value is just that number we found. So let's put that present value as a negative number. Okay, and then he wants to know how much money he can withdraw, and when this person, in the end of the retirement, this person is going to die. So put 0. Compute for payments. So this person can withdraw $91,501.73. So as you can see that this is very important concept. Time value of money is very important. It can help you to choose between investment. It can help you to plan your retirement. You can use time value of money for capital budgeting. So there is a wide use of time value of money concept in finance. Therefore, it's very important topic in finance. Another application is if you want to know the value of a firm, if you want to know the value of a bond, in other words securities, if you want to know the value of a stock, okay, so you can use time value of money concept. Conceptually, a firm should be worth the present value of all firm's cash flows, future cash flows. But the tricky part is knowing the size, timing, and risk of those cash flows. That's the really tricky. Value or price of any security is the sum of the present value of all future cash flows. Okay, so even though the size of and the timing and the risk of the cash flows is very difficult, it is very tricky, still we're gonna use the time value of money concept to determine the value of each security. Therefore, time value of money is the key concept in finance. If you understand time value of money, I think it is gonna be so easy for you to do other problems in finance, because here and there in every topics we are dealing with time value of money concept. Going forward, you're gonna use you're gonna find bond value, you're gonna find stock value, you're gonna use capital budgeting. So time value of money is everywhere. Okay, therefore it is very important to understand this time value of money concept. I hope this lecture series, this lecture video will help you understand time value of money concept. Thank you.